Beneath the waves lies a frontier more alien than space, where pressure is extreme and life is stranger than fiction. The deep ocean covers over 70% of our planet, yet we have explored less than 5% of it. In this vast unknown, we are about to embark on a journey to the most remote and inhospitable environments on Earth. Chapter: Dark Depths, about why the deep ocean is Earth's final frontier. The deep ocean is characterized by an almost complete absence of light, with the last remnants of sunlight barely penetrating beyond 200 meters. Below this point, bioluminescence becomes the primary source of light, with creatures like the anglerfish using it to lure prey and communicate. The darkness is total, with some areas receiving as little as 0.001% of the sunlight that reaches the surface. For example, the Mariana Trench, the deepest point in the ocean, receives only a fraction of the sunlight that filters down from above, resulting in an environment that is both harsh and alien. In fact, it's estimated that only about 5% of the ocean has been explored, with much of the deep sea remaining a mystery. The National Oceanic and Atmospheric Administration estimates that there are between 700,000 and 1 million species in the ocean, but only about 226,000 have been formally described. This lack of knowledge highlights the need for further exploration and research into the deep ocean, which is essential for understanding the complex ecosystems that exist within it. Chapter: Crushing Pressure, about why the deep ocean is Earth's final frontier. As we descend into the deep ocean, the pressure increases exponentially, reaching over 1,000 times the pressure at sea level in the deepest trenches, such as the Mariana Trench, which has a recorded pressure of 1,086 bar. This is due to the weight of the water above, which is so great that it would crush anything that tried to withstand it, with some areas experiencing pressures of over 480 times that of the standard atmospheric pressure. Yet, life finds a way, with creatures like the deep-sea fish, such as the anglerfish, and giant tube worms adapting to these extreme conditions, with some species even thriving in environments with temperatures near freezing and total darkness. For example, the giant tube worm can survive in pressures of up to 800 times that of the standard atmospheric pressure, and in temperatures of just a few degrees above zero, a true testament to the incredible diversity and resilience of life on Earth, with scientists estimating that up to 75% of all marine species remain undiscovered, and the deep ocean covering over 70% of the planet's surface. In the deep ocean, hydrothermal vents support a unique community of organisms that thrive in the harsh conditions surrounding these underwater springs, with over 700 species identified so far. Giant tube worms, such as Riftia pachyptala, and vent crabs, like Bythagria thermidron, cluster around the vents, using bacteria that can survive in the hot, chemical-rich fluids to produce energy through a process called chemosynthesis. This ecosystem is independent of sunlight, with the vents providing a constant source of energy and nutrients, allowing these organisms to survive in the dark depths of the ocean. For example, the vent ecosystem near the East Pacific Rise supports a vast array of life, with some vents hosting over 10,000 individual organisms per square meter. The unique conditions surrounding hydrothermal vents have also led to the discovery of new species, such as the giant vent eel, and have provided scientists with a glimpse into the Earth's early history, with some vents believed to be similar to those that existed over 3.5 billion years ago. Chapter: Unmapped Territory, about why the deep ocean is Earth's final frontier. The deep ocean remains one of the most poorly mapped regions of our planet, with some areas having been explored less than the surface of the moon. The general bathymetric chart of the oceans estimates that over 80% of the ocean floor remains unmapped, with new discoveries being made regularly. For instance, in 2020, the 5 Deeps expedition, led by Victor Vescovo, became the first team to reach the lowest point in each of the world's 5 oceans, including the Mariana Trench in the Pacific Ocean, which is approximately 36,000 feet deep. This expedition not only set a new record but also collected valuable data and samples from these unexplored regions. Furthermore, according to the National Oceanic and Atmospheric Administration, it's estimated that up to 75% of all marine species remain undiscovered, highlighting the vastness and mystery of the deep ocean. As technology advances, we are slowly uncovering the secrets of this final frontier, with ongoing efforts to map and explore the ocean floor, such as the Nippon Foundation JEPCO Seabed 2030 project, which aims to create a comprehensive map of the world's oceans by 2030. Chapter Future Exploration, about why the deep ocean is Earth's final frontier. As technology advances, we are becoming increasingly capable of exploring the deep ocean. Autonomous underwater vehicles, or AUVs, can now map the seafloor in unprecedented detail, covering over 200,000 square kilometers of ocean floor in a single mission, while submersibles like the Deep-Sea Challenger have taken humans to the deepest parts of the ocean, including the Challenger Deep, which reaches a depth of approximately 11,000 meters. The next generation of explorers will use advanced technologies like artificial intelligence and robotics to uncover the secrets of the deep ocean and push the boundaries of human knowledge. For example, the Woods Hole Oceanographic Institution is currently using AUVs to explore the ocean floor, discovering new species and ecosystems, with over 200 new species discovered in the past decade alone. Explorers like Victor Vescovo, who has reached the lowest point in the ocean, are also paving the way for future generations of deep-sea explorers, with many expecting that the deep ocean will yield many more discoveries in the coming years. The deep ocean is a frontier that is still largely unexplored, but with each new discovery, we are drawn deeper into its secrets. Join us next time as we explore the mysteries of the ocean's twilight zone, and don't forget to subscribe for more documentaries on the wonders of our planet.